Bright Tuty. Every student matters.
Now, one thing I would like to clear that sometimes we try to use this word loudness and intensity interchangeably. I repeat, what exactly loudness and intensity, we use it interchangeably at times, but it is not the case. When I am talking about the intensity of the sound waves, I am saying that this is the amount of sound energy. This is the amount of sound energy passing each second through unit area. I repeat, when I talk about the intensity of the sound, I am talking about the amount of sound energy that is passing each second through unit area. Sometimes we relate this intensity with the loudness, but they are not the same, because loudness, what is loudness? It is the measure of the response of the ears to the sound, right? How our ears are responding to the sound. So, even though there are two sounds having the same intensity A and B, we may hear one sound to be louder and another sound to be a bit less louder, simply because our ears are able to detect the first sound properly. And when we are talking about sound, there are a few terms that we use in our day to day life. For example, I am talking about tone. Now, what exactly is meant by tone? A sound of single frequency, that is known as a tone, right? And if there is a sound which is a mixture of frequencies, then it is not known as a tone, it is known as a note. Just try to relate how we have differentiated. I have just used the same alphabets T-O-N-E and T-O-N-E, but just by interchanging the alphabets, I have got two words which have got different meanings. What is tone? It is the sound of a single frequency, and if there is a mixed frequency sound, it is known as a note. This note is always pleasant to ears. It is musical sound, different notes we talk about. And if it is an unpleasant sound, we call it a noise, not notes, right? So, these are a few terms which are used when we talk about the sound waves: the tone, the note, the intensity, the frequency, the loudness, everything, right? So, whenever sound waves strike any surface like a wall or any object, right, then they will reflect after striking. Now, a human ear has the tendency of listening to these sound waves, and these sound waves are in turn sent to the brain. Now, the human brain has this sensation of sound for 0.1 second. So, the sensation of sound which persists in our human mind, that is 0.1 second. What does it mean? It means that if we want to differentiate between two different sounds, there must be a gap of 0.1 second between them. Otherwise, we will listen to the sounds, but we will not be able to distinguish between them. Alright. So, now what I do is, if I clap, if I produce some sound from such an object like a very tall building or from the mountain, then what happens is that my own sound, it reaches my ears after this 0.1 second, and therefore, I hear that sound again. You must have seen this is common phenomena. You must have experienced yourself that whenever you go to mountainous regions, there you clap and the sound it is reproduced, or you rehear that. That reflected sound wave, when you hear it again, that is known as echo, right? Now, for hearing our own sound again, we have seen that there must be a difference of 0.1 second between the sound and the reflected sound. So, if we try to calculate how much minimum distance is required by a sound wave, so that when it travels that minimum distance, it should reach our ears after 0.1 second, we can very easily calculate it. For example, keeping the time to be 0.1 second, I need to calculate the distance travelled by the sound wave, and I know that the speed of sound wave is let us take 344 meter per second, which is at room temperature, which is taken to be 22 degrees Celsius. Alright. So, now I know that speed is equal to distance upon time. For calculating the distance, I will simply multiply speed into time. Speed of sound wave is 344 meter per second, multiply by time we are taking is 0.1 second. Removing the decimal, dividing it by 10, I will get 34.4 meter, cancelling second with second. So, this is the distance which should be travelled by the sound wave at 22 degrees Celsius. If we are taking the temperature, then we will hear the echo of this particular sound. Now, one important thing, students, I am, for example, standing here, right, I am producing some sound from this point. I am saying that the total distance travelled by the sound wave should be 34.4 after reflecting from a particular object or a surface. So, if this is the distance travelled after reflection, that means the sound wave has to go, strike a particular surface and reflect back, and total distance is 34.4 meters, it is both sides. So, if I want to take the single side distance, it will be half of it, which comes out to be 17.2 meter. So, to understand it better, now let us relate it in normal terms, that a distance of 17.2 meter is required if I am producing a sound and the sound wave is going to a distance of 17.2 meters, and in between there is no reflecting surface. After that, it will reflect with any particular object, and when it comes back travelling a total distance of 34.4 meter, I will hear the echo. So, this is the minimum distance required one way. The total distance required for an echo to be produced is 34.4 meter. You need to remember it. Plus, we have already studied that the speed of sound depends on various factors like temperature, like the material, the medium, like the humidity. So, we are assuming this is the distance at 22 degrees Celsius in air when the speed of sound is 344 meter per second. At various temperatures, different temperatures, it will vary. So, at some places the speed of sound may be a bit more, so we will hear the echo accordingly, and at some places if the temperature is less, accordingly we will hear the echo, and accordingly it will be the distance, different distance travelled by the sound for echo to produce, right. Now, in the case of mountains, we see that there are so many times that the sound is reflected. Why? Because there are many reflecting surfaces. Same is the case in the case of thundering. When lightning occurs in the atmosphere and we listen to the thunder, that is also because the sound is multiple times reflected with the buildings, with the land, with the clouds, lot many things, right. So, this is echo. Got it? Now, when we talk about echo, let us see one or two questions based on this particular topic. First is, a person clapped his hands near a cliff, a mountain peak, and heard the echo after 5 seconds. So, the time which is represented by small t is given to us to be 5 seconds. What is the distance of the cliff from the person if the speed of the sound v is taken to be 346 meter per second? So, we are taking the speed represented by small v to be 346 meter per second. Simply, we have to calculate the distance of the cliff from the person. We know that distance is the product of speed and time. Speed is given to be 346 meter per second. Time is given to be 5 seconds. Simply multiplying it, I will get 1730. These many meter. But this is the total distance travelled by the sound. If we have to calculate one way, it will be half of it. That means it comes out to be 865 meter. So, this is the distance of the cliff from the person. Why we have reduced it to half? The same that we have studied earlier, that this is the person, and if this is a particular cliff, right, from where he is just clapping his hand, it is striking a surface somewhere, it is sound is travelling this way, and after reflection it is coming back. So, it is covering a total distance of 1730 meters. So, we have to calculate half of it, which is 1865 meter. Got it? Let us see one more example. An echo returned in 3 seconds. Time given to us once again is 3 seconds. What is the distance of the reflecting surface from the source, given that the speed of sound is now 342 meter per second? Speed of sound, that is v, is given to be 342 meter per second. Again, we have to calculate the distance travelled by the sound, that is s. Now, we know that the distance is one way and the way back. So, I can take this is basically 2d, twice the distance that actually the sound wave is covering, that is equal to the product of v and t. So, once again I will do the same thing, I will take the half of it. This 2 I am dividing it up here on the other side, because I need to calculate half in order to know the distance of this particular reflecting surface from the source. Putting the values, I get v is equal to 342, time is given to be 3 seconds, divided by 2. Just simply I will cut it off and I will get 171 into 3, which comes out to be 513 meter. That is my answer. So, this is the distance, or represented by small s, this is the distance of the reflecting surface from that particular source, right. So, this is about echo.